Right, children. Now we are going to start the exercise of this lesson. So first we are going to start to do the exercise given in the textbook. Now remember children, like always, you all have to write the answers for all the questions and then you have to watch what I teach here and you can compare your answers with my answers. Okay, children? Right, let's start. Question number 1. Underline the most appropriate word to fill in the blank. Let's go through this. The warmth of an object is called heat, temperature. What is the answer, children? Now, heat is a type of energy. That warmth of an object is called, what is the answer? Temperature. Right. Number 2. When we heat up a container with boiling water, its temperature rises, does not change. Now, do you remember we did this activity to understand how the heat or the temperature changes of a certain liquid? Do you remember we heated water? So, while heating water, you all observe that the temperature of the water increases. And at one point, the water started to boil. So, do you remember when we were observing the temperature change during the time of the water was boiling? What happened, children? It remained the same. So, what was this temperature, children? That was 100 degrees Celsius. Okay, so it did not change. So, what is the answer? When we heat up a container with boiling water, its temperature does not change. With boiling water, no. So without boiling water, just the water at room temperature, if you heat it, what will happen? Its temperature rises. But here it mentions container with boiling water, which means at boiling temperature. So there, while the water is boiling, the temperature does not change. Right. Number 3. Ice steam forms when heat is released from water. You all know that change of states of matter takes place because of absorption of heat and because of release of heat. So what happens when we provide heat to a solid? The solid starts to melt. That happens because of absorption of heat. When a certain object absorbs heat, what happens to its temperature, children? Increases. Okay, so because of absorption of heat, solid starts to melt, which means the solid turns to its liquid. So when we further heat a liquid, what will happen to the liquid? The liquid converts to its gas. Okay, now here, ice or steam forms when heat is released from water. So in the same way, because of absorption of heat, what happens? Solids turn into liquids, liquids turn into gas. So what happens because of the release of heat? You all know that because of release of the heat of gases, it turns back to its liquid. When the liquids release its heat, what happens? It turns into its solid. Okay, children. So we can show this like this way. We'll consider water. Ice turns into water and water turns into water vapor. Right? Ice turns into water, water turns into water vapor. This happens when we heat this by heating. Right. In the same way, water vapor turns into water again by cooling. And water turns into ice due to cooling. Right. So here, the heating, due to heating, because of absorption of heat, ice turns into water, water turns into water vapor. So due to cooling, when we cool something, the object, the substance releases its heat. Therefore, water vapor turns to water and water turns to ice. Okay? So here, forms when heat is released from water. When heat is released from water, what is formed? Ice. Okay? Right. Number 4. When heat is released from a solid substance, what happens? When heat is released from a solid substance, it expands, contracts. You all know when objects absorb heat, what happens to the size of the objects? Increases. And the volume also increases. Right, children? So when a certain object or a certain substance releases its heat, what happens, children? The size and the volume reduces. Okay? So when heat is released from a solid substance, what happens? Its volume reduces and this is known as contraction. So answer, contracts. When iron is heated thoroughly, it turns red or white first. So do you remember, due to heat, color change takes place. So when we heat something like a metal, what happens? First the metal turns red color, then the metal turns orange color, then yellow color, and finally white color. So the first color change is red. Okay? When iron is heated thoroughly, it turns red or white first. First it turns red, it turns white last, finally. Okay? Therefore, first it turns red. Number 6. In room temperature, mercury is in the liquid or solid state. What is mercury? Mercury is a metal. Not only a metal, it is a liquid metal. Do you remember we learned about mercury? That mercury is used to fill the thermometer bulbs. Okay? So it is a liquid metal. Okay? So in room temperature, mercury is in the liquid state. Right. Number 7. Currents, tsunami occurs as a result of the changes in the temperature of seawater. You all learn that water currents occur because of temperature changes. Okay? Tsunami is not a result of temperature changes. Okay? So, currents occurs as a result of the change in the temperature of seawater. Right? Okay. The warmth of an object is called temperature. When we heat up a container with boiling water, its temperature does not change. Ice forms when heat is released from water. When heat is released from a solid substance, it contracts. When iron is heated thoroughly, it turns red first. In room temperature, mercury is in the liquid state. And currents occurs as a result of the changes in the temperature of seawater. Right? We'll move on to the next. Right. Number 2. What is our main source of heat? You know that there are different sources of heat. What is the main source of heat? That is the sun. Right? There are other sources as well. By burning fuel also we can obtain heat. Okay? But the main source of heat is the sun. The sun. Right. What are the instances where we use heat in our day-to-day life? There are many instances. Now the sun's heat is used to dry clothes, to dry food items like chili and sometimes lime. Okay, even sometimes to dry fish also we use the sun's heat. Okay, children, and to cook food. In order to heat food, we have to heat produced in different ways. Okay, children, let's write some of them. What are the instances where we use heat in our day-to-day life? To dry clothes. to dry food items. To cook food. What else? Why to iron clothes we need to use the iron and its heat. To iron clothes. Right, children? To dry clothes, to dry food items, to cook food, to iron clothes. Right? So these are some instances. You can find many other instances and make your list longer. Right? We'll move on to the next. Number 3, part 1. What is the reason to leave a little space among the rail tracks when they are made? Now you all know the reason. What is the reason? Because when we consider 2 rail tracks, what happens, children? During the daytime, they expand. Right? So if we did not leave space, what happens? When they expand, now during expansion, their length increases. Okay, their length increases and therefore we have to leave space in order to increase the length. Otherwise, what happens? If we did not leave space, what will happen? If they present too close, they don't have enough space to increase the length because of expansion. Therefore, what happens? These rail tracks, they will bend sideways. To prevent this, we have to leave a gap between 2 rails. Okay, let's write. What is the reason to leave a little space among the rail tracks when they are made? To prevent the bending of the rail tracks due to expansion. Okay? To prevent the bending of the rail tracks due to expansion. Okay? What is the strategy used in electric irons to control the heating? Now, about this strategy, you all are going to learn in detail in the upper grades, okay? But here I will explain a little. Now, when we consider electric irons, you all know that when it gets heated up, sometimes they automatically go off. So then the heat reduces. Then again, when its heat reduces, it automatically gets heated up again while we are plugging it into the main plug point. Okay, children? So how does this take place, children? Because something called a bimetallic strip is connected to the circuit of the iron. What is the meaning of a bimetallic strip? Bi means 2, right? So a special metal strip made by combining 2 types of metals. Okay? It's something like this. Right? It's a type of metal strip, but it is made by combining 2 different types of metals. So it is fixed to the circuit of the iron. So when electric current passes through this metal strip, what happens, children? It gets heated up. Because it gets heated up, it expands, which means its length increases. Okay? Because we have used 2 different types of metals to make this bimetallic strip, because they have different ways of expanding, they expand in 2 different levels. Okay, so we'll consider this strip is A, this strip is B. Right? So one of these metals expand more than the other one. So let's consider, when you consider A and B metals present in this bimetallic strip, if A expands more, which means by absorbing heat, A's length increases more than that of the B. Right? Now, because they are fixed from the top and the bottom, this cannot expand upwards. So when it expands, it takes a curvy shape like this. Right, children? Now, if you look at these A and B, if you look at the lengths of these strips, you can understand this A's length is higher than that of B. Now, here we consider that A metal expands more than that of B. Right? In that case, A's length increases more than that of B. Okay? So, when it changes the shape, it goes and touches another part of the circuit and it acts as a certain type of switch. Okay, children? So, when it touches the switch, it automatically goes off. Then again, this iron cools down a little. Right? Then again, what happens? This comes back to the normal position. Again, the electric current passes through the circuit. Again, it gets expanded and turns the shape and it changes the circuit. Likewise, this can act as a switch. Understand, children? So, you are going to learn about these type of bimetallic strips more in detail in the upper grades. Here, just mentioning the term is enough. Right? So, what is the strategy used in electric irons to control the heating? Fixing a bimetallic strip. Right? Fixing a bimetallic strip. Okay, children? Right. Now we have completed the activity or this exercise given in the textbook, but we are going to do some extra questions as well. We are going to start them now. Right. Exercise number 1, underline the most suitable answer. Okay. Let's go through them. The normal temperature of human body is. What is the normal temperature of a healthy human, children? 50 degrees Celsius, 37 degrees Celsius, 100 degrees Celsius, 0 degrees Celsius. What is the answer? 37 degrees Celsius. Okay? Right. We learned this before. Number 2. There are 3 statements. A. The body is covered with fur. B. Presence of a thick fat layer under the skin. C. Presence of dry skin without glands. Okay? The adaptations that help to maintain the body temperature are. So, what are the adaptations, children? Now, do you remember I explained about these things considering polar bears? Polar bears living in polar regions, they have to protect their body heat because the outside environmental temperature is very, very low. Right? Therefore, they have to prevent the loss of heat from their bodies. Right? So, do you remember I explained you all that their body is covered with fur or fur coat. Right? So, the body is covered with fur is an adaptation that helps to maintain the body temperature. Therefore, this is correct. A. Presence of a thick fat layer. Now, I told you all when animals have this thick fat layer, that fat layer acts as an insulator, which means through that layer, heat cannot pass. Okay, therefore, this is also important to maintain the body temperature. Okay. C. Presence of dry skin without glands. It doesn't have any effect on maintaining the body temperature. Okay. Therefore, the adaptations that help to maintain the body temperature are, what is the answer? A and B. Okay. So, A and C. This is the answer. A and B. Right. Next one. The main natural source of heat is. Now, earlier also we answered this question. What is the main natural source of heat? That is the sun. Right. Number 4. Select the correct statement. The body temperature of snakes and frogs changes according to the temperature of the environment. Do you remember we learned about 2 different types of animals according to the body temperatures, children? They are warm-blooded and cold-blooded animals. What are the warm-blooded animals, children? Warm-blooded animals' body temperature does not change along with the or according to the environmental temperature because they can regulate a constant body temperature. But cold-blooded animals, their body temperature changes with the environmental temperature. Right, children? So who are coming under the warm-blooded animals, children? Mammals and birds are coming under the warm-blooded animals. And who are coming under the cold-blooded animals? The animals who change the body temperature according to the environmental temperature. So who are the cold-blooded animals? We learned that fish, reptiles and amphibians are coming under the cold-blooded group. Okay. So the body temperature of snakes. Now snakes are reptiles and frogs. Frogs are amphibians. Okay. The body temperature of snakes and frogs changes according to the temperature of the environment. Right? So snakes and frogs are cold-blooded animals. So cold-blooded animals' body temperature changes according to the temperature of the environment. This statement is true. Right? This is correct. But we are going to read the other statements as well. The body temperature of snakes and frogs does not change according to the temperature. That's wrong. Only warm-blooded animals' body temperature does not change according to the environmental temperature. But snakes and frogs are coming under cold-blooded. Right? Next one. The body temperature of snakes and humans does not change according to the temperature of the environment. So when it comes to humans, humans are warm-blooded animals. So humans' body temperature does not change. So when we consider the humans, this is correct. But what about snakes? Snakes are reptiles and reptiles are cold-blooded animals. Their body temperature changes with the environmental temperature. Therefore, this is wrong. Okay. Last one. The body temperature of snakes and fish does not change according to the temperature of the environment. This is also wrong. Does not change. Now here these are cold-blooded animals. Snakes and fish come in under cold-blooded animals. Cold-blooded animals' body temperature changes with the environment. Therefore, does not change is wrong. Therefore, it's clear that the correct answer is the first one. Right. The body temperature of snakes and frogs changes according to the temperature of the environment. Right? Next one. A suitable device to be installed on the roof of the house to heat water. What is this? Solar water heater. Do you remember we made a model solar water heater? Right? Asbestos sheets, solar water heater, aluminium sheets, plastic sheets. Answer number 2. Next one. The most commonly used pair of heat sources in homes today is. Now we all know that at home we use different sources of heat, especially to cook food. Right? So what are the main methods of or main sources of heat that we use, children? We'll go through them. Cow dung, firewood. Firewood is still used in some houses, but cow dung, in some countries, cow dung is used as a source of heat because dried cow dung can be burned and obtain heat. But this is not a very commonly used method, right? Now here, the most commonly used. This is one method of obtaining heat, but this is not one of the most commonly used methods, okay? Firewood, kerosene oil. Firewood is used, but kerosene oil, most of the time we don't use kerosene oil hearths or kerosene oil cookers as a very common method, right? Coconut shells and firewood. Coconut shell sources some people use, but not widely used, right? Firewood and LP gas. This is the most commonly used methods of sources of heat. Okay, so most of the time in urban areas, LP gas is used. In rural areas, in villages, firewood is most of the time used. Okay, so this is the most widely used methods. Firewood and LP gas. Most commonly used pair of heat sources to obtain heat, right? Next one. An instrument that can be used to get an idea of the heat gained or released by an object. What is the instrument, children? Thermometer. To measure the temperature, we can use thermometers. According to the increase and decrease of the heat, The temperature of an object also increase and decrease. To measure the temperature, we can use thermometers, right? Barometer, thermometer, anemometer, hygrometer, right? Thermometer. Next one. If an object has cooled, it has released heat. You all know that when we heat an object, what happens? It absorbs heat, right? When an object, if an object has cooled means because it releases its heat to the environment. That's why it has cooled down. Therefore, if an object has cooled, it has released heat. It has absorbed heat? No. There's no effect of heat? No. Cannot say anything? No. The correct answer is it has released heat. So when an object releases its heat to the environment, we call it cools down, right? It has released heat. Next one. The increase of substances in size upon heating is called. What is this, children? Contraction, vaporization, expansion, condensation. What happens to the objects when they absorb heat? What happens to the size and the volume, children? Size and the volume of the objects increases, right? The matter increases because of absorption of heat, right? The increase of substances in size upon heating is called, what is this, children? Expansion. Right. Number 10. A balloon that was inflated in the morning burst in the afternoon. Why does this happen? You must have experienced this. Right? A balloon. So when we inflate a balloon, there's a certain amount of air present inside the balloon. Right? So in the afternoon, especially if we leave this balloon outside, exposed to sunlight, what happens? This balloon gets heated up. Therefore, air particles inside the balloon also gets heated up, and what happens to the air? The volume increases or expansion takes place. So when they expand, here expansion of a gas means its volume increases. Because of the increased volume of this gas, it creates a pressure on the balloon membrane. Okay, children? So when this pressure increases, what happens at one point when this balloon membrane cannot tolerate this pressure, this bursts. Okay? So due to the expansion of air, that is correct. Due to the expansion of liquids, no. Inside the balloon, when we inflate a balloon, air is present. Okay? Due to the expansion of solids, no. Right? None of the above. So inside the balloon, air is present. Therefore, this happens because of the expansion of air. Okay? Due to the expansion of air is the answer. Next one. Solids convert into its liquids upon heating is given in. Solids convert into its liquids. Right? Let's consider the first one. Camphor. Camphor is a solid. Convert into camphor vapor. Now, camphor vapor is a gas. The gaseous state of camphor is known as camphor vapor. Right? Ice into water. Now, you have to find the answer where solid converts to liquids. Right? Now, this one solid to gas. Second one, ice to water. That is correct, right? Ice is solid, water is liquid. We'll go through the next two as well. Water vapor to water. Now, water vapor is a gaseous state. Water is liquid. So, here gas to liquid. And here water to ice means liquid to solid. So, the answer with solids convert into its liquid is the second one, ice to water. Next one. Change of color is an effect of heat. We learned this as well. An example that does not belong to this is, we'll read them. Discoloration of clothes. You all know that after washing clothes, we hang them outside to dry. Okay, so sometimes what happens, some type of clothes, you all know that, especially the clothes with dark colors, we can observe that with time, its color reduces. Okay, so discoloration of clothes. This happens because the color changes because of the heat. Right, children? Change in the color of the filament of a bulb. So when we supply electricity to the bulb, what happens? The filament gets heated up. Therefore, its color changes from red to orange to yellow to white. Right? So this is also correct. It's an effect. Okay? Heat in a piece of iron. This also we discussed. When we heat a piece of iron, the same changes, the color changes take place. Right? Red to orange to yellow to white. Right? Ripening of fruits, it doesn't have anything to do with this heat. Okay, change of color is an effect of heat. An example that does not belong to this is ripening of fruits. Right. A phenomenon. What is the meaning of phenomenon, children? Which means incidents, right? A phenomenon caused by heat in the oceans. Now, I think you can understand this, right? Occurrence of sea waves. No, that doesn't happen because of heat. Occurrence of ocean currents, that is correct. Why does this happen, children? Do you all remember? When we consider the earth, what happens? Different parts of the earth gets heated up in different ways because of sun. So when we consider the equator area gets heated up faster than that of the polar regions. Right? Because the equator of the earth gets sunlight directly, a lot of sunlight. Therefore, oceans and seawater present in this equator area gets heated up faster than that of the polar regions. So this hot water goes to the polar regions and the cold water from the polar regions comes to the equator area, and this moving of water from the polar regions to the equator and from the equator to the polar regions is known as water currents, right? So this is correct. Occurrence of tidal waves and occurrence of tsunami waves, they don't take place because of heat change, okay? Therefore, a phenomenon caused by heat in the oceans is occurrence of ocean currents. The main gas that is responsible for global warming is, there are a number of gases responsible for global warming, right? Carbon dioxide, methane, water vapor are some of them, right? But the main gas that is responsible for global warming, what is the meaning of global warming? The Earth's temperature increases, right? Increase of the temperature of the Earth is known as global warming, right? So carbon dioxide gas, oxygen, nitrogen, hydrogen are not the answers, right? Carbon dioxide gas, right? Next one. A factor to be considered when measuring the temperature of a liquid in a vessel. Now we measured the temperature of water in vessels. Do you remember while heating the water, we measured the temperature? So how to do this, children? You all have to remember when we measure the temperature of a liquid. How do we do this? We have to fill the beaker with the liquid, and then when we immerse the thermometer, we have to make sure that the bulb of the thermometer completely present inside the liquid, right? The bulb of the thermometer should be completely immersed in the liquid. It should not touch the walls or the bottom of the vessel, okay? Right. The bulb of the thermometer should be completely immersed in the liquids. That is correct. The bulb of the thermometer should touch the bottom of the vessel. No, it should not touch. A tall vessel should be used. It is not a necessary factor, right? Even with a small vessel, we can still measure the thermometer. The thermometer should be taken out before reading it. No. Remember, children, if you want to measure the temperature of this water, what you have to do? You have to measure it. You have to read the thermometer while the thermometer bulb is still inside the water. Otherwise, what will happen? When you take out the thermometer, because of the reduction of the temperature, you cannot get the correct reading. Okay, so when you get the reading of the thermometer, you have to read the thermometer while the bulb is still inside the water. Okay, so the thermometer should be taken out before reading it, also wrong. So the correct answer is the bulb of the thermometer should be completely immersed in the liquid. Okay, right. Next one. The temperature of the following places was measured. The highest temperature could be seen. Do you remember we measured the temperature of 2 soil samples and 1 water sample? Right? So let's go through this. The highest temperature could be seen under a large tree. We measured the temperature of a soil sample taken from under a large tree. And we measured another temperature of another soil sample taken from a place where there is plenty of sunlight. And the third sample was pond water. So we observed clearly the temperature of the soil sample where we taken from the places where plenty of sunlight present, its temperature was the highest. Why does that happen? That type of soil gets heated up faster because it gets direct sunlight. Okay. So the highest temperature could be seen in a place where there is plenty of sunlight. Okay. So under a large tree, no, it's shady. Therefore, soil does not get heated up fast, right? Inside a tree hole also, it's very cold, okay? Because it does not get sunlight properly, okay? At a place where there is plenty of sunlight, this has to be the answer. At a place where water is gathered, no. Because water can absorb heat, a lot of heat. Therefore, temperature of water rises slowly. Right? Therefore, highest temperature could be seen at a place where there's plenty of sunlight. Right. 70. When an equal amount of water and coconut oil is heated, the liquid that heats up faster is. Do you remember we did this activity, children? We heated up coconut oil and water, the same volumes of water and coconut oil during the same time period in the same way. Right? So you all observe that coconut oil gets heated up faster than that of the water during the same time period. Okay, so actually this happens because water has a special ability to absorb a lot of water. Right? So therefore, the liquid that heats up faster is coconut oil. Water, water and coconut oil, water or coconut oil, coconut oil. Coconut oil is the answer. Next one. An animal in which the body temperature changes according to the environmental temperature. You all know that the body temperature, if the animal's body temperature changes according to the environmental temperature, that animal has to be a cold-blooded animal. Who are coming under cold-blooded animals? Fish, reptiles and amphibians. Right? So we'll go through the answers. Bat, parrot, python, dog. So when you consider bat and dog, they are mammals. Mammals are warm-blooded, right? Parrot is a bird. Birds are also warm-blooded, which means their body temperatures do not change along with the environmental temperature because they maintain a constant body temperature, right? But when it comes to python, python is a reptile. Reptiles' body temperature changes along with the environmental temperatures, right? So answer is python. Right. Look at this picture carefully. You all can see there are 3 setups. Okay, you all can see equal volumes of liquids present. In the first one, hot water. In the second one, cold water. The third one, lukewarm water, we can consider normal temperature, water at normal temperature. 3 thermometers are immersed in these 3 beakers, right? So the lowest temperature can be seen in lowest temperature. Hot water, cold water, lukewarm water. So here, cold water has the lowest temperature. In which setup the highest temperature present? Obviously in the hot water, right? So the lowest temperature can be seen in the cold water, which means B. Setup A, B, C, the temperature of all three setups are equal. No, this can't happen, right? So cold water is the answer, setup B. Okay, right. Next one. When a bottle filled to the brim with water was immersed in a hot water basin, the water in the bottle overflowed. This shows that now here when a bottle filled to the brim up to the mouth with water was immersed in a hot water basin. Let's consider if this is the bottle and this is the mouth, right? And it has water filled up to the brim. Right? So we have to immerse this water bottle in a hot water beaker. Hot water. So this is hot water. Right? When a bottle filled to the brim with water, it's this, was immersed in a hot water basin. This is the hot water basin. The water in the bottle overflowed. Why does this happen, children? You all know water is a liquid. Now, when you compare this normal water, outside temperature is higher. Therefore, this water bottle, the bottle with water, this water absorbs the heat of this hot water. Right? Because of absorption of heat, what happens to the liquids, children? They expand. So during expansion, what happens to the volumes of the liquids? The volumes increase. Right? The volume increases, therefore the increased volume goes out. So when we immerse this water bottle in hot water beaker or hot water basin, what happens? Because of absorption of heat, this water inside the bottle expands because the water is filled up to the mouth, up to the brim, right? That water, the increased volume of water doesn't have anywhere else to go other than overflowing, going out. Okay, children? So when a bottle filled to the brim with water was immersed in a hot water basin, the water in the bottle overflowed. This shows that, what is the reason? The volume of the bottle decreases with heat. No. Right? When solids, liquids, gases, when they absorb heat, what will happen, children? Because of absorption of heat, its volume increases. Right? The volume of water decreases with heat. Volume does not decrease. The volume of water increases with heat. That is correct. The weight of the water increases with heat. No. Weight will be the same, but the volume of water increases with heat. Okay, that is the answer. Right? Okay. When a gas is heated, what happens? When a gas is heated, the gas expands, its volume increases, right? When a gas is heated, its volume increases, correct. Volume decreases? No. Volume doesn't change? No. Volume always increases because of heat, okay? Weight increases? No. Nothing happens to the weight, but the volume increases. Next one. The most correct statement about expansion due to heat is, let's read them. Only gases expand. No. All the solids, liquids and gases, they all expand. And we did experiments to study these three. Only gases expand, only water expands, only liquids expand. No. Solids, liquids and gases all expand. That is the answer. right? A liquid used to fill the bulb of a thermometer is. What are the commonly used liquids, children? We use mercury and alcohol or colored alcohol because alcohol is a colorless solution. We cannot use colorless alcohol. We cannot observe how it changes clearly. Therefore, we always use colored alcohol, right? So water, no. Marine water, no. Coconut oil, no. Alcohol, yes, we use alcohol. Right. Okay, we'll move on to the next. Right. Exercise number 2. We have to write the answers, okay? Number 1. Suggest a method to remove a metal lid that is tightly attached to a bottle. Metal lid. What is the easiest method? We already discussed this in the lesson. How to remove this, children? We can hold the metal lid onto a flame. Directly we can hold the metal lid onto a flame. Or another method is there. We can simply pour some hot water onto the lid. What will happen, children? When we heat the metal lid, by any means, we have to heat the metal lid. So what happens when we heat the metal lid? The metal lid absorbs heat and it expands. Expand means its size increases. So when its size increases, we can easily remove the lid from the bottle. Okay, let's write. Suggest a method to remove a metal lid that is tightly attached to a bottle. Heat the lid. Heat the lid. We'll write the method. By holding onto a flame or by pouring hot water. Pouring hot water. Okay. Heat the lid by holding onto a flame or by pouring hot water onto it. Okay. Explain what happens when you remove the lid using the above method. What happens I already explained. When we heat the lid, because of the absorption of heat, what happens to the lid? It expands. So the size increases. Thereby, we can remove the lid easily. Okay? Explain what happens. When the lid is heated up, it expands. Write within brackets, size increases. Therefore, it can be removed easily. Okay? When the lid is heated up, it expands, so size increases. Therefore, it can be removed easily, right? Okay. Exercise 3. Fill in the blanks using the words given within brackets. You all can see some words given. Expansion, contraction, poles, polar regions, 100 degrees Celsius, condensation, liquid, mercury, right? First question. The temperature at which water boils is. Do you remember during the activity while we were heating the water, the temperature of the water increases gradually. At one point, the water started to boil. What was this temperature, children? It was 100 degrees Celsius, right? The temperature at which water boils is 100 degrees Celsius. Okay? Number 2. When heat is supplied to solid iron, it turns into its. What happens? When the solid iron is a type of metal, right? So when you heat it for a long period of time, what happens? It turns to its liquids. Because you all know when we supply heat, the change of state of matter takes place. right? So when heat is applied to solid iron, it turns into its, what is the answer? Liquid. Right? Number 3. A tight bottle lid can be removed by heating it up. Now, earlier we explained this, right? A tight bottle lid can be removed by heating it up due to the, what happens when we heat it up? It expands due to the expansion of it. Okay. Number 4. When the temperature rises, the glaciers of, where can we find glaciers? In the polar regions, right? The glaciers of the poles start melting. That is also a change of state. Because of absorption of heat, glaciers means ice, solid, turns into its liquid, okay? 5. Contains in bulb thermometers. You all know that the liquids contained in bulb thermometers, mercury or alcohol, right? Mercury. Right. Next one. Clouds form due to the blank of water vapor in the atmosphere. Do you remember I explained you all about the water cycle? There I explained that in the atmosphere there is water vapor, which means the gaseous water. There in the atmosphere it cools down, its temperature reduces and the gaseous water changes to water droplets, right? This is known as condensation. So because of the water droplets formed by condensation, clouds are made, okay? So clouds form due to the condensation of water vapor in the atmosphere. Condensation. Right. The last one. The wire, which has increased in length during heating, shortens due to what happens? When we heat objects, they absorb heat. Because of absorption of heat, their size increases. This is known as expansion. When they release heat, what happens? They cool down, and when they release heat, what happens, children? Their size decreases, and this is known as contraction. Okay? The wire, which has increased in length during heating, shortens due to what happens? This happens because of the contraction, right? Contraction during cooling. Right? Okay. The temperature at which water boils is 100 degrees Celsius. When heat is applied to solid iron, it turns into its liquid. A tight bottle lid can be removed by heating it up due to the expansion of it. When the temperature rises, the glaciers of the poles start melting. Mercury contains in bulb thermometers. Clouds form due to the condensation of water vapor in the atmosphere. The wire, which has increased in length during heating, shortens due to contraction during cooling. Right? We'll move on to the next. Okay. Exercise number 4. Look at the setup. There's a bottle here and a balloon is fixed. Right? Number 1. What can be observed when the above bottle with a slightly inflated balloon? You all can see the balloon is a little inflated. Right? Air is filled here. What can be observed when the above bottle with a slightly inflated balloon is immersed in a basin with ice water? What happens, children? Now we did not do this type of activity. But can you imagine what would happen when we do this activity, children? This setup, when it is immersed in a cold water or ice water basin, what will happen, children? You all know that because in the water basin ice present, this setup's temperature reduces. Right? This setup's temperature reduces. Now this bottle, what is present inside, children? Even though we can't see, air is present. We did the same activity in a different way. Do you remember we fixed a balloon to an empty bottle and we immersed this bottle in a hot water beaker? What happened to the balloon? The balloon inflates. Right? There what happens, children? Because of absorption of heat, the air expands, which means its volume increases. When its volume increases, the increased amount of volume gathered inside the balloon. Okay, therefore the balloon inflates. Here what happens? The exact opposite takes place here. Instead of the hot water, we have to immerse this setup in basin with ice water beaker. Then what happens, children? The setup cools down. You all know that because of release of heat, the substances, air, water, all the other liquids and even the solids, they contract, their size reduces, their volume reduces. Okay, children? So what happens when air is present inside? When we immerse this bottle in ice water, this setup cools down and thereby, because of release in heat, the volume of the air present inside reduces. Right? The volume reduces, and when the volume reduces, the air present even inside the balloon also comes inside the bottle. Therefore, the balloon that is already inflated slightly will deflate. Because when the air present inside the balloon goes inside the bottle, what happens? The balloon deflates. Okay, that would be the observation. Let's write. The balloon deflates. So because of release of heat, the substances cool down. When they cool down, their volume and the size reduces. Okay. So when the volume decreases, what happens? The volume of air present inside the balloon comes to the bottle. Therefore, the balloon deflates. Okay. Next one. Number 2. What can be observed when the above bottle with the balloon is immersed in a basin with hot water? So first, this was the setup, slightly inflated balloon. With the bottle, we have to immerse it in ice water. Then what happens to the balloon? The balloon deflates. So then we have to take this setup, the bottle with the deflated balloon, and you have to immerse it in hot water. What happens, children? You all know because of hot water, the air inside the bottle absorbs heat and the air expands. Expansion means the volume of the air increases. The increased amount of volume goes inside the balloon again, and therefore, because of filling of air inside the balloon inflates. Okay, let's write. Here the balloon inflates. So this happens because of the contraction. This happens because of the expansion. Okay? Right. Next one. Exercise number 5. What is the instrument that is made using the changes that occur in a liquid when it is heated or cooled? You all know that when we heat a liquid, it expands and its volume increases. Right? What happens when we cool a liquid? When it is heated or cooled. When we cool a liquid, because of the low temperature, what happens? It contracts. Using this theory, what is the instrument that is made using the changes that occur because of expansion of contraction? According to the liquids, we can make a certain instrument. What is the instrument made? Thermometer. So what happens when we consider the thermometer? Thermometer has a bulb like this, So when the bulb absorbs heat, now the bulb is filled with either mercury or alcohol, right? When the bulb absorbs heat, what happens? The liquid inside the bulb expands and it increases through the tube. Okay? So when the bulb releases its heat, what happens to the liquid? The liquid contracts and then the level of the liquid inside the capillary tube reduces. Okay, so using this theory, we can use the thermometer. Okay? Right, next one. Write an instance where the air heats up and rises is beneficial. So what happens when we heat air? So you all know that hot air, when we heat air, because of the absorption of heat, the air expands or the volume increases. Right, children? So remember, children, the hot air rises up. Why does that happen, children? Because the density or the thickness of the air, when it gets heated up, the thickness or the density of the air also reduces. Okay, therefore what happens? That hot air rises up. Okay, so write an instance where the air heats up, rises is beneficial. Remember, children, this is very beneficial in formation of wind. I will explain you all how formation of wind takes place. So let's consider this is the earth. You all know that the atmosphere is made up of different types of gases, air present here, right? So you all know during the daytime, different parts of the earth gets heated up at different levels. Let's say that if this part gets heated up more than this area, then what happens? Because of absorption of heat, what happens to the earth? The temperature of earth increases. When the earth gets heated up, what happens? Next to the earth, air present. The air layer right next to the earth also gets heated up here. So I told you all, when the air gets heated up, it becomes light, less heavy, and it goes up. Less heavy things go up, right? So air becomes less heavy or it becomes light and this less heavy air goes up. Right? Heavy things come down. Then what happens? Now earlier air particles were present here. They got heated up and because of the absorption of heat, they go up. Then what is present here? This area, the number of air particles reduces. But compared to this side, the other sides have more air particles. So a kind of gap is created here. Right? So what happens? To fill this gap, to fill this space, air comes from the surroundings. Right? Air comes from the surroundings and this flowing air is known as, what is the name given? Wind. The flowing air is known as wind. Right, children? So you all know that this happens because the air gets heated up. You all know that wind is very important factor in the environment. Right? We need wind in our day-to-day lives. Okay? So what happens? Write an instance where the air heats up and rises is beneficial. So wind occurs, wind takes place because in certain areas, air pressure reduces and air particles go up. Right? To fill the spaces, air comes from the surroundings with a certain speed and this flowing air is known as wind. Right? So air rises up because the air particles next to the earth level gets heated up. Right? So because of heat, air rises up and because of this rising of air, wind forms and wind is very important. Therefore, this becomes beneficial. The heating of air and its rising is important in formation of wind. Okay, let's write. Write an instance where the air heats up and rises is beneficial in formation of wind. In formation of wind. Okay, children? We'll move on to the next. Okay, exercise number 6. Right. Look at this setup. Do you remember we did this activity? Right, what you have to do is name A, B, C and D. What is A? Look at this one. A is the beaker. Right? What is B? B is the tripod. Okay? C? C is the spirit lamp and D is the laboratory stand. Let's write. A is the beaker. B. B is the tripod. C is the spirit lamp. And D, laboratory stand. Right? Beaker, tripod, spirit lamp, laboratory stand. Okay? Next one. How to adjust the thermometer to measure the temperature of the water accurately. Accurately means very correctly. Right? How to adjust the thermometer to measure the temperature of the water accurately. Now we discussed this same topic under one of those questions, right? How to adjust the thermometer, children? When you fix the thermometer, so we are going to measure the temperature of water. So if you want to measure the temperature of water or any other liquid, you all know that you have to immerse the bulb of the thermometer completely in water. Right? So the bulb should be completely covered with the liquid, children. If part of the bulb is outside, the reading won't be correct. Okay? So the bulb of the thermometer should be completely immersed in water. That is number 1. Right? And remember, when we fix this thermometer and when this is inside the beaker, this thermometer bulb should not touch the bottom or the walls of the beaker. Right? Because we are going to measure the temperature of the water here. Therefore, the bulb of the thermometer should be surrounded by water of the liquid or any other substance that we are going to measure the temperature of. Okay? So it should not touch the walls of the beaker or the bottom of the beaker. Right? There's another important thing. When you take the reading, when you read the temperature of the liquid, you should not take out the thermometer and read it. Right? While you are reading the thermometer, the bulb of the thermometer should be still inside the liquid. Right? Otherwise, what will happen? The moment you take out the bulb out of this water, because the outside temperature is less than that of water, because here we are heating water, what happens, children? The mercury column drops because the bulb feels the temperature of the outside environment, not the temperature of the water. Therefore, what happens? Because of reduction of heat, the mercury column drops. Right? Therefore, when you read the thermometer, the bulb of the thermometer should be still inside the water. Right? Let's write this. How to adjust the thermometer to measure the temperature of the water accurately. Number 1. The bulb of the thermometer should be completely immersed in water. Next one. The bulb of the thermometer should not touch the walls or the bottom of the beaker. Next one. The reading should be taken while the bulb of the thermometer is inside the liquid. Write within brackets, should not take it out. Okay? The bulb of the thermometer should be completely immersed in water. The bulb of the thermometer should not touch the walls or the bottom of the beaker, right? The reading should be taken while the bulb of the thermometer is inside the liquid. Then only we can measure the temperature of the liquid, right? So it should not take it out, right? We'll move on to the next. Right, next one. The reading of the thermometer should be taken while it is inside the beaker. What is the reason for this? Now I already explained this one, because when you take out the thermometer, what happens? Now when the thermometer bulb is inside the water, according to the water's temperature, that heat is absorbed by the liquid inside the bulb, right? So therefore, according to the absorption of heat, its mercury column increases. So what happens when you take it out? Because the outside temperature is less than that of hot water, therefore the heat absorbed by the bulb of the thermometer is less, and instead it releases heat. Right, children? Therefore what happens? Because of release of the heat by the bulb of the thermometer, what happens? The mercury column drops. Right? Therefore, if you want to measure the temperature of the water, you have to do so when the bulb of the thermometer is still inside the water, right? Let's write. The reading of the thermometer should be taken while it is inside the beaker. What is the reason? Let's write. Because when the thermometer is taken out, due to the releasing of heat due to the releasing of heat, the mercury column drops. And the correct temperature cannot be taken. Okay? Because when the thermometer is taken out, due to the releasing of heat, the mercury column drops and the correct temperature cannot be taken. Okay? Right. Next one. If the reading obtained in the above setup is 100 degrees Celsius, write it down with proper units. How to write it down, children? 100 degrees Celsius. First you have to write 100 degrees by this and Celsius, capital C. Okay, 100 degrees Celsius. Right? We'll move on to the next. Right, next one. The setup given in the diagram was prepared by a student who wanted to study a certain change that occurs in liquids upon heating. Look at this one. This is the exact experiment that we did. What we have to do, now this is the bottle with ink and we fixed a tube of pen, empty pen tube, and then we could observe the level of the ink inside the pen tube. And then we immerse the whole setup in a hot water beaker. What did you all observe, children? So earlier, the level of the ink inside the empty pen tube was up to a certain level. But after immersing this bottle inside hot water, in this hot water beaker, what did you observe, children? The level of the ink inside the empty pen tube increases. Why does this happen, children? You all know that when we immerse this colored water bottle in hot water, this colored water absorbs heat and thereby the water expands. The colored water expands. So expansion of liquids means the liquid volume increases, right? When the volume increases, there's no space inside the bottle because the bottle is filled up to the mouth. Therefore, the increased volume goes up through the empty pen tube. Okay? We'll go through these things. What can be proved by engaging in this activity? So, it's very clear when you engage in this activity, because of the rising of the liquid inside the empty pen tube, we all know that that happens because of expansion of liquids, right? So, what can be proved? That liquids expand upon heating. This is what we can prove. What can be proved by engaging in this activity? That liquids expand upon heating, right? Write the observation of this activity. What is the observation? When this bottle is immersed in hot water, the level of colored water inside the empty pen tube increases, right? Let's write. When the colored water bottle or with ink bottle is immersed in hot water, the water level inside the pen tube, what happens? Goes up. Right, children? Write the observation of this activity. When the colored water bottle is immersed in hot water, the water level inside the pen tube goes up. Right? You see the next one? What is the reason for using colored water? Why can't we use normal water? You all know that when we use colored water, we can observe very clearly that it goes through the empty pen tube. Right? For clear observation. If we use water, because water is colorless, the observation is not very clear. Right? So what is the reason for using colored water? For clear observation. For clear observation. Right? Next one. Why is it preferable to place the bottle containing colored water in hot water without heating it with a flame? What is the reason, children? Just imagine, without immersing this colored water bottle inside the hot water beaker, what if we heat it up from the bottom only? This takes time, right? So if we use a flame from one side, you all know that only the bottom part of this water will get heated up, right? So here, if this is the colored water bottle with an empty pen tube, like this, and if you heat it with the flame from the bottom, if you heat the bottom, what will happen? So only the bottom part will get heated up well, right? So to take the observations, we have to wait for a longer time period. Okay, because from the bottom part, it little by little gets heated up. But what happens when we immerse this bottle in hot water? All the areas of the bottle gets heated up evenly and faster, right? That is why it is better to use a hot water beaker other than heating it up using a flame, right? Let's try. When the bottle is heated with a flame, only the bottom part of the bottle gets heated up well. Okay. When the bottle is immersed in hot water, the entire bottle gets heated up evenly and faster. Okay? Why is it preferable to place the bottle containing colored water in hot water without heating it with a flame? When the bottle is heated with a flame, only the bottom part of the bottle gets heated up well, right? When the bottle is immersed in hot water, the entire bottle gets heated up evenly and faster. Why? From everywhere it gets the same heat. Okay? We'll move on to the next, number 5. Write the name of an instrument made based on the changes that occur in this activity. So what is the change occurs in this activity? Because of absorption of heat, what happens to the liquids? Here the colored water expands. Based on the expansion of liquids, what is the instrument made, children? Thermometer. You all know that the bulb of the thermometer contains a liquid. When it absorbs heat, it expands, and when that expands, what happens? It goes through the capillary tube present in the thermometer. Right, children? So write the name of an instrument made based on the changes that occur in this activity. Thermometer. Thermometer. Right? Next one. Write 2 types of liquids that can be used in making the above instrument. To fill the bulb of the thermometer, we can use two types of liquids. What are the liquids? Mercury and alcohol. Let's write. Mercury and alcohol. Right? Mercury and alcohol. Right? Next one. Okay. Exercise number 8. Underline the correct answer. Our main source of heat is the sun when? The main source of heat is the sun. Right? Number 2. When the temperature rises, ice in the polar regions is changed into. What happens? Because of the temperature rise, ice or the solid water turns into its liquid. Change of states of matter. Right? When heat is provided to ice, what happens? They melt, which means they turn into water, right? When the temperature rises, increases, ice in the polar regions is changed into water vapor, water. Water is the answer. When electricity is supplied to a small torch bulb, what happens to the color of the filament? Changes, right? So, do you remember the order of color change, children? First it turns to red, then it turns to orange, then it turns to yellow and then to white. Okay. When electricity is supplied to a small torch bulb, first it will turn, what is the color? Red. And at last it will turn, what is the color? White. Next one. Water vapor comes out of the spout of the kettle. What happens when we heat water? At one point, the water boils. Water boils means the liquid water changes to its gas, which means water vapor. Right? That water vapor comes out of the spout of the kettle, right? Water vapor or steam. So, answer is water vapor comes out of the spout of the kettle. 5. When water vapor is cooled, it turns into, you all know that when the water vapor is the gaseous state, when the gaseous state is cooled, then what is made? The liquid state. So when water vapor is cooled, it turns into liquid water. Right? The liquid in a thermometer is silver color. What is this liquid? There are two types of liquids that we can make to fill the bulb of the thermometer. What are those liquids? Mercury and alcohol. So when it comes to alcohol, because alcohol is a colorless solution originally, to observe it clearly, we use colored alcohol. What is the silver color substance? The silver color liquid is the mercury. Mercury is a liquid metal. That metallic color is the silver color, right? The liquid in a thermometer is silver color. This liquid is mercury. 7. When heat is supplied to an object, what happens? When heat is supplied to an object, it absorbs heat and its temperature increases, right? When heat is supplied to an object, its heat temperature increases. Its temperature increases. Okay, we'll move on to the next. Right. Next exercise. Name two sources of heat. We all know there are many sources of heat. What are they? The main source of heat is the sun. What are the other sources? Different types of fuels like fossil fuels, right? And firewood can be used to obtain heat, right? We can name two sources. Sun, firewood. Coal can be written. Okay. Next one. What is the common name by which firewood, coal, kerosene, etc. can be called? What is the common name given, children? We can call them fuels. What is the fuel? Fuel is something, a substance that can be used to burn and obtain heat. Right? What is the common name by which firewood, coal, kerosene, etc. can be called? Fuels. right? We'll move on to the next exercise number 10. Do you remember we did this activity? Right. The diagram shows how a wire is wrapped around a pencil, right? What can be observed when electricity is supplied to this wire for about 2 minutes? Now, this is the activity that I told you all. I can feel the wire gets warmer. The coil of the wire gets warmer. You could not observe this, but if you do this activity, you will feel the same, right? So when we supply electricity to this system for about 2 minutes, what happens, children? This coil of wire gets warmer, right? Let's write. What can be observed when electricity is supplied to this wire for about 2 minutes? The coil of wire gets warmer. Right? What is the name by which this coil can be called? You all know that these type of coils are known as heat-in coils. So we use heat-in coils in different types of electrical appliances. Hot plates, water heaters, these type of heat-in coils are used. Okay, children, what is the name by which this coil can be called? Heat-in coils. Heat-in coils. Next one. Name an appliance with such a coil. Now, I already explained you all. You can write. There are different appliances. Let's write water heater. Right, children? We'll move on to the next. Right. Exercise number 11. Do you remember even this activity we all did? What can be proved by engaging in the above activity? Here, what did we do? Do you remember? We made a loop like this. This B is an iron loop, and here during the activity we used as A an iron ball. You can even use a marble, okay? Now here A is an iron ball and B is iron loop. So originally when we place this iron ball on the loop, it does not go through the loop, right? Which means the loop is smaller than that of the iron ball. That is why the ball cannot go through the loop. Okay. So then what did we do, children? We heated this iron loop, right? This metal loop was heated. So after heating the loop, when we place this iron ball, what happened, children? It nicely goes through the loop. Why does this happen, children? When we heat, now earlier the ball did not go through the loop because the loop was smaller than that of the ball. For the ball to go, we have to make the loop bigger. In this case, when we heat, because of expansion of solids, what happens, children? It becomes bigger, so that the iron ball goes through the loop easily, right? So what can be proved by engaging in the above activity? So when you engage in this activity, finally we can come to a conclusion that all these things happen. After heating the loop, the iron ball goes through the loop, which means when we heat, the loop expands. Now this loop is made of solids, therefore this is a good activity that can be proved that the solids expand, okay? What can be proved by engaging in the above activity? That the solids expand. That the solids expand. That the solids expand. Right? Name A and B. What is A? Iron ball. B is iron loop. A, iron ball or marble. B, iron loop. Right, children? Number 3. What happens to A when B is heated? Right? When B is heated, A goes through the loop easily. Right? When B means the iron loop. is heated, A. Iron ball goes through B easily. Right? What happens to A when B is heated? Now A is iron ball, B is iron loop. When B is heated, A goes through B easily. Right? What is the reason for the above observations? So when the iron loop is heated, it expands and its size increases. Therefore, the iron ball can go through it easily. Right? What is the reason? When the iron loop is heated up, its size increases due to expansion. Right? That is why this observation is possible. When the iron loop is heated up, its size increases due to expansion. Right? Write 3 instances where solid expansion is used. Solid expansion is used in day-to-day life. What are the instances, children? Do you remember? We can prevent train accidents by leaving a gap between 2 rails. Because during the daytime, when the rails get heated up, they expand. Thereby the length increases. If we did not leave a gap, what will happen, children? They will expand and they will bend sideways. Right? Therefore, accident might occur. What are the other instances, children? You all know that we can remove a bottle lid that is tightly fixed to a bottle by heating because of the expansion. Right, children? We'll write these things. Right. Number 1. 3 instances. To prevent train accidents by leaving a gap between 2 rails. Next one, to remove a metal lid tightly fixed to a bottle. What is the 3rd instance? Do you remember I explained you all how a metal frame is fixed to a cartwheel? By expanding the metal frame, by heating the metal frame, when it expands, we can nicely insert the cartwheel inside the metal frame. Right? That is also a use. An instance where solid expansion is used. To fix a metal frame to a cartwheel. Right? To prevent train accidents by leaving a gap between 2 rails. To remove a metal lid tightly fixed to a bottle. To fix a metal frame to a cartwheel. Right? So these are the instances and you can find more examples for these things. Right? We'll move on to the next. Right. The last exercise in this lesson. Look at this one. Even this activity we did in the lab. What can be tested by engaging in the activity given in this diagram? So what is this, children? We used an empty glass bottle and we placed a coin on the mouth of the bottle and then we immerse that glass bottle in hot water. This is hot water. This is the empty glass bottle and this is the coin. Then what did we observe, children? The coin moves up and down. Why does this happen? Even though the bottle looks empty, it is filled with air. So when we immerse this bottle in hot water, because of absorption of heat, the air expands. When the air expands, what happens? The volume of the air increases. So as the bottle is closed with the coin, the expanded amount or the increased volume of air doesn't have anywhere to go other than going out. So when it goes out, it moves the coin up. That is the reason for the movement of this coin up and down. Okay. So by doing this activity, we can prove that the air expands upon heating. Okay. What can be tested by engaging in the activity given in this diagram? We can test the expansion of air or gases, right? Expansion of air, right? Or gases. I'll write that. Name A, B and C. What is A? A is the coin. What is B? Empty glass bottle. Empty glass bottle. What is C? Hot water. Right? A is the coin, B empty glass bottle, C hot water. Number 3. Write the observation obtained when B is immersed in C. What happens when we immerse this empty glass bottle with the coin on the top? When it is immersed in hot water, what happens? The coin moves up and down, right? The coin moves up and down. Okay? What is the reason for the above observation? Now I already explained you the reason. This happens because of expansion of air inside the glass bottle. So when the air expansion takes place, the volume increases. The increased volume of air goes out by moving the coin up. Right? We'll write. What is the reason? This happens due to the expansion of air. When air absorbs heat, its volume increases. This increased volume of air, goes out of the bottle by moving the coin up. Right? What is the reason for the above observation? The movement of the coin. This happens due to the expansion of air. When air absorbs heat, its volume increases, expands, right? This increased volume of air goes out of the bottle by moving the coin up. Right, children? We have completed the entire lesson now. Do you remember what we learned under this lesson, children? We learned how to generate heat, what are the effects of heat, and we did a lot of activities as well. Most of these activities you all can do at home very easily. And we answered a lot of questions. I hope you understood the lesson clearly. You can write the answers. You can go through the questions again and try to write the answers again to understand this lesson more.